Welcome to day 24 of our school year. Let's fill in that square. Okay, let's get down our beginning fraction. Our denominator is 180 because it's our total amount of school days, and our numerator is 24. So we need to find our factors of our numerator, 24. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can write it down as 12 times 1. Now I'm going to go through my divisibility rules in an orderly fashion. So after 1, I try 2, 3, 4. I need to go in order so I don't miss any possible factors. The rule for 2 is that it ends in an even number. 4 is even, so 2 is a factor. 2 times 12. Oh, I put 12 here for some reason. Silly me. 2 times 12. 12 times 2. Okay, then the rule for 3 is that we add the digits together. 2 plus 4 equals 6. 6 is a multiple of 3, so 3 is a factor. 3 times 8. 8 times 3. So we're making all these factor pairs. 1 and 24 is a factor pair. 2 and 12 is a factor pair. 3 and 8 is a factor pair. We try 4. One way to check is the factor with 2 even? The second factor? Yes, it is. 4 will be a factor. 4 times 6. 6 times 4. Now all we have to check is our counting number or natural number between 4 and 6, which is 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 4, so 5 is not a factor. We get to 6 and we are done. Let's list these from least to greatest. 1, 2, 3, 4, 6, 8, 12, 24. Well, we have 2, 4, 6, 8 factors. That is not exactly 2 factors. That is more than 2 factors, so it is composite. Now we need to figure out which one of these factors is the greatest common one. Common means it works for both numbers. We want the largest number or the greatest number that works in dividing both numbers. So let's start with 24. And then if that doesn't work, we'll go to 12. It doesn't matter what your groups of 24 look like, as long as you have 24 in each and you do not have your shaded in with your unshaded. I'm going to use decomposition to help me here. 6 plus 10 is 16, plus 8 is 24. 2 plus 20 is 22, plus 2 is 24. 18 plus 6 is 24. 4 plus 20 is 24. 24. 16 plus 8 is 24. I have a remainder of 12, so that means that 24 is not a factor of 180. So that doesn't work. So now let's go ahead and make our groups of 12. Again, it does not matter what your groups of 12 look like, as long as you have 12 in each and you do not have your shaded in with your unshaded. Okay, so I've gotten all my shaded into groups of 12. So here 6 plus 6 is 12. 8 plus 4 is 12. 2 plus 10 is 12. 10 plus 2 is 12. 8 plus 4 is 12. 6 plus 6 is 12. 4 plus 8 is 12. We end up getting a pattern going on here. Now, I'm using logic and reasoning to help me make these groups. Those are mathematical practices that help you be a strong mathematician. But if you aren't able to see that, counting always works. It's better to get to the right answer slowly than the wrong answer quickly. And if counting is what you need to do to make your groups, then you need to do that. Well, no remainder. Everything's in a group of 12, so that means 12 is our greatest common factor. So let's go ahead and count up our total amount of groups of 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I have 1, 2 shaded in. Okay, so now let's prove it with our long division, since we've done our division with our model. We're going to divide by our greatest common factor. It always has to be something that works for both. You can't try a number that works for one and not the other. It has to work for both as a factor. And they're always going to be the same because I put the whole thing into groups of 12 and the shaded area into groups of 12. So let's do 180 divided by 12 and 24 divided by 12. So let's try one of my favorites, 10 times 12, because 10 just moves everything over a place. Every place is 10 times greater. So when you multiply by 10, it moved the 10 to the hundreds, the ones to the tens, and then we put our placeholder, because every place is 10 times greater to the left. Numbers the same, zeros the game, more on top, no need to stop. Let's see, I know 2 times 12, I could get 24. Here I have more on the floor, go next door, regroup 10 more. So now I have 5 tens. I add that 10 to 0, and I get 10. 10 take away 4 is 6. 5 take away 2 is 3. 2 times 4 is 24. More on top, no need to stop. More on top, no need to stop. I get 12. Oh, and then 1 times 12 is 12. Numbers the same, zeros the game. Now you may have already realized that 5 times 12 was 60 and you got to the answer quickly, and that's fine. I just want you to see that there's more than one way to get to that right answer. 10, 11, 12, 13, 14, 15 is our quotient. Now here, now I could do 2 times 12, but say you didn't know that, you can always do 1, because division is repeated subtraction. If you can take out large groups, subtract large groups at a time, go for it. But if you have to do it one at a time, you will get there. More on top, no need to stop. More on top, no need to stop. Okay, and then 1 times 12 is 12. Numbers the same, zeros a game. Add up our partial quotients, we get 2. Now we need to do our inverse operation to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder is 0 on both, I don't actually need to add 0 because the identity property of addition says when you add 0, it stays the same. And if it's going to just stay the same, we don't need to do that. 12 times 15 is 2-digit by 2-digit. And we don't do the standard algorithm for that. So we're going to use the area model this time. And 15 I'm going to break apart into its expanded form of 10 plus 5. And then 12 I'm going to break up in its expanded form as 10 plus 2. I'm going to make these boxes a little bigger. Now 12 times 2, I can do the standard algorithm, so that's fine. 10 times 10. Well, I have 2 placeholders, so it's going to move it over 1, 2 places. 1 times 1 is 1. Then 10 times 5 is 50. 2 times 10 is 20. 2 times 5 is 10. So in this area model, we have our partial products. So I'm just going to list them. So I have 100. Now this is where you need to be careful to line up from the ones. So 50, I line up the zeros here, and then the tens place. 20, line up the zeros and the tens. 10, line up the zeros and the tens. 0 plus 0 plus 0 plus 0. 0 plus 5 plus 2 is 7 plus 1 is 8. And then 1. 2 times 2 is 4. 2 times 10 is 20. So 180 matches our dividend of 180. Check. 24 matches our dividend of 24. Check. So that means 2 is definitely our numerator and 15 is definitely our denominator. Okay, now it's time to fill in our data collection page. Okay, it is still trimester 1, week 6. Today is 9, 11, 19. And our fraction for today is 2/15. Let's go ahead and get out our number line. We did groups of 12. So the last one we have 1/15. Here is 2/15. And we have an equivalent fraction in the 6s, in the 4s, the 3s, the 2s, and here that 24 180ths. These are all equivalent fraction, but this is our simplest form, or the one in lowest terms. All right, go ahead and put your number line away, erase your worksheet, and thank you for joining me.